leakage current test, measure the insulation resistance in PV modules and measure the wet leakage current of a PV module. Did you know? The use of conductors and their insulation is regulated by IE regulations and BIS Code of Practice. Two fundamental properties of insulation materials are insulation resistance and dielectric strength. They are entirely different from each other and measured in different ways. Damage of insulation can result into loss of power, overheating of equipment, and even fires. Insulation resistance is the electrical resistance of the insulation against the flow of current. Hence, insulation resistance to be maintained to ensure safety. Please remember, the insulation resistance quality of an electrical system degrades with time, environment condition, that is, temperature, humidity, moisture, and dust particles. Megometer. Mega is the instrument used to measure insulation resistance. It measures high resistance values in megohms without causing damage to the insulation. The measurement serves as a guide to evaluate the condition of the insulation. Insulation resistance testing is used to identify faults to the insulation by testing the integrity of wiring and equipment. The purpose of the IR test is to check for damaged insulation. This can be mechanical damage or damage by heat, overloaded cables. Readings less than 2 megohm indicate damaged insulation. Readings of 2 to 50 megohm are indicative of long circuit lengths, moisture and contamination, and do not indicate the insulation quality. Here comes the principle behind insulation resistance test. By injecting a known DC voltage lower than the voltage for dielectric testing and then measuring the current flowing, it is simple to determine the value of the resistance. The insulation resistance test is an electrical safety test and shows whether a solar module offers adequate insulation. Let's see IE rules regarding voltage drop concept. As per IE Rule 48, the insulation resistance between the wiring of an installation and earth should be of such a value that the leakage current may not exceed 1 by 50,000 the part or 0.02% of the FL current. The permissible voltage drop in a lighting circuit is 2% of the supply voltage plus 1 volt. The maximum permissible voltage drop in a power industrial circuit should not be more than 5% of the declared supply voltage. The insulation resistance of any wiring installation should not be less than 1 M and the earth resistance should not exceed the value of 1 ohm. In an insulation testing using Mega, we send a test voltage down through an electrical system to check if there is any leakage of current which is going to be passed through the insulated wiring of all the appliances of the machine. The Mega supplies over 500 volts and that is enough to give a fatal shock. The cable that is to be tested may be used in AC lines and the Mega uses DC as the testing voltage. Clamp the alligator clip on one of the Mega probes to the wire or cable, touch the other probe to the exposed conductor and press the test button. The Mega will generate a current between the probes and the meter will record the resistance of the jacket to the flow of the current. If you are testing insulation resistance to ground, place the positive probe on the ground wire or the grounded metal junction box and the negative probe on the conductor or terminal. Energize the Mega for 1 minute. Read the value of the resistance at the end of the minute test and note it in your table. The wet leakage current test is an electrical bearing test on various electrical equipment to ensure it can withstand moisture or wetness from outdoor conditions. This test is significant because it evaluates the solar panel's insulation against penetration of moisture under wet environmental conditions. Weather conditions like rain, morning dew, or fog can lead to moisture penetration, which can cause corrosion, ground fault, and electric shock hazard. Here comes the procedure to measure the insulation resistance in PV modules. Ensure you have all the following tools and equipment. Grid-connected PV systems composed of multi-crystalline silicon panels of 1 MW size. Systems with negative ground and floating ground for comparisons. Megometer. Connecting wires. Set of PV modules and water tank. Connect the megometer between the negative terminal of the string and the grounded support structure as shown in the figure. Connect the positive probe to the negative pole of photovoltaic string. Connect the negative probe to the support structure or ground cable. Set the megometer at 1000 volt DC. Operate the megometer for 2 minutes without the light. Measure the insulation resistance value and record. Measure and record the insulation resistance of each PV string. Repeat the test under hot and humid climatic conditions to compare the results. Record the observations. Please note that the leakage current test result is normally presented in the insulation resistance form for the easier testing and monitoring. Possible results. The leakage current test of the PV string sampled of negative grounded and floating grounded PV systems. Typical results. Ensure you have all the following tools and equipment: PV module, water tank, megometer and connecting wires. The procedure to be followed to measure wet leakage current is as follows. Put the PV module inside the water tank. Connect the positive probe of megometer to the negative pole of the module. Connect the negative probe of the megometer to the support structure. Operate the megometer for 2 minutes without the light. Measure the insulation resistance to estimate wet leakage current. Record the observation. Sample of 20 modules for about 1100 modules in a mega plant are to be checked. Repeat the steps for all 20 samples and record the observations. We have reached the end of this session on to measure insulation resistance and wet leakage current of PV modules. By now, you should be able to know about the insulation resistance, explain the importance of measuring insulation resistance in PV modules, know the significance of wet leakage current test, measure the insulation resistance in PV modules, and measure the wet leakage current of a PV module.
Hello students, welcome to this module on refrigeration and air conditioning. In this session, we are going to know about tracing the electrical circuit of a frost-free refrigerator.
Objectives. By the end of this exercise, you will be able to identify the electrical circuit of a frost-free refrigerator. Trace the electrical circuit of a frost-free refrigerator. Dismantle all electrical parts in a frost-free refrigerator. Ensure that all electrical parts of the frost-free refrigerator are in a good condition. Use a clamp meter or tongue tester to check all electrical parts of the frost-free refrigerator. Let us now take a look at the tools, equipment, and consumables needed for tracing the electrical circuit of a frost-free refrigerator. Tools, equipment, and consumables. Trainees tools kit, tongue tester or clamp meter, cutting plier, screwdriver, test lamp, voltmeter and ammeter, knife, defective frost-free refrigerator, insulation tape, multi-core wire 3 meters, wire clip, cotton waste. Now, let us see the preparations needed for tracing the electrical circuit of a frost-free refrigerator. Task 1. Dismantling of all electrical parts from frost-free refrigerator. Ensure the refrigerator is completely unplugged from the power source before starting any dismantling work. Wear safety gloves and goggles to protect against sharp edges or electrical hazards. Refer to the refrigerator's schematic diagram to identify the locations of various electrical components such as the compressor, fans, and control boards. Some components might be behind panels or covers, depending on the refrigerator model. To access internal components, carefully unscrew or unclip the outer panels. Take note of the positions of screws or clips and keep them organized for reassembly. Start the process of disconnecting electrical connectors from various components. Remove the compressor relay clip and relay. Note down the colors of wires while removing. Remove relay wire and junction wire, paying attention to their connections. Unscrew and remove the thermostat switch, noting its position and connections. Unscrew the fan blade and remove the freezer fan motor. Remove the light switch and light holder along with bulbs. Unscrew and remove the timer switch and strip heater wire only. Organize all dismantled components systematically for the checking process. Ensure that you have all the necessary checking kits ready for examining the components. Now, let us see the process for tracing electrical circuit of frost-free refrigerator. Task 2. Checking all electrical parts removed from frost-free refrigerator by clamp meter or tong tester. Use protective gear. Wear safety gloves and goggles to protect against potential hazards. Understand the clamp meter's function and settings for measuring resistance, continuity, and voltage. Arrange all the electrical components removed from the refrigerator in a clean and organized workspace. Set the clamp meter to the continuity test mode. Touch the probes together to ensure the clamp meter is functioning and emits a sound or indicates continuity. Compressor inspection. For the compressor, set the clamp meter to measure resistance. Connect the clamp meter to the compressor terminal and check for continuity. Connect the black lead to the compressor top terminal C and the red lead of the meter unit to compressor R terminal. The meter should show ohms. Without removing the black lead, touch the red wire to the compressor S terminal. This will give starting winding ohms. Without removing the black lead, touch the red wire to the compressor body. If you get ohms, the compressor motor is burnt out. Otherwise, winding is okay in normal condition. Refer to the refrigerator manual or technical specifications for the expected resistance values. If the reading significantly deviates from the expected values, the compressor might be faulty. Check the relay. Inspect light holders and light switch. Defrost heater and thermostat inspection. Check the defrost heater and thermostat, setting the clamp meter to resistance mode. Check the resistance across the terminals of each component. Compare the measured resistance with the specified range in the manual. Any significant deviation from the specified range might indicate a faulty part. Fan motors inspection. For condenser and evaporator fan motors, set the clamp meter to resistance mode. Check the cooling coil fan motor. Place the probes on the motor's terminals and check the resistance. Again, refer to the manual for expected resistance values. A reading significantly different from the expected value might indicate a faulty motor. Check timers for visible signs of damage, burnt marks, or bulging capacitors. Use the clamp meter to test for continuity across different points on the board as per the schematic diagram. Recap.
In this topic, we came to know about how to
Identify the electrical circuit of a frost-free refrigerator. Trace the electrical circuit of a frost-free refrigerator. Dismantle all electrical parts in a frost-free refrigerator. Ensure that all electrical parts of the frost-free refrigerator are in a good condition.
I hope you all understood the process of tracing the electrical circuit in a frost-free refrigerator. Thank you, students, and let's meet in the next session. Bye. Hello, students. Welcome to this module on refrigeration and air conditioning. In this session, we are going to know about checking, fault finding, and testing of electrical accessories like thermostats, timers, defrost heaters, bimetal air louvers, and other system components.
Objectives. By the end of this exercise, you will be able to check and test timer, check and test bimetal thermostat, check and test defrost heater, check and test PTC relay, check and test overload protector, check and test the evaporator fan motor. Let us now take a look at the tools, equipment, and consumables needed for checking, fault finding, and testing of electrical accessories like thermostats, timers, defrost heaters, bimetal air louvers, and other system components. Tools, equipments, and consumables. Clamp meter or tong tester. Line tester 500 volts. Cutting plier length 200 millimeters. Nose plier length 150 millimeters. Screwdriver set. Multi-strand wire 5 meters per 1 square millimeter. Bulb holder. Electrical test board. dry ice. Frost-free refrigerator. Now, let us see the preparations needed for checking, finding faults, and testing electrical parts like the thermostats, timers, defrost heaters, bimetal air louvers, and other system components. Task 1. Checking and testing bimetal thermo in a frost-free refrigerator. Set up a test lamp as per the provided diagram. Identify the bimetal thermostat in the refrigerator, usually positioned near the evaporator coils or in the freezer compartment. Remove any necessary covers or panels to access the thermostat. If applicable, unscrew or remove protective covers. Set the clamp meter to measure resistance in ohms. Ensure the clamp meter is appropriately set for resistance measurement, typically in the kilo ohms. Check continuity between points A and B of the bimetal. If the bulb of the test lamp does not glow, the bimetal thermo is functioning correctly. Place the bimetal thermo in dry ice for 5 minutes. After 5 minutes, check continuity between points A and B. If the test lamp bulb glows, the bimetal thermo is operating properly. Task 2. Checking and testing the defrost heater in a frost-free refrigerator. Find the defrost heater typically found behind the rear panel of the freezer compartment. It may appear as a coiled wire or a glass tube. Inspect the defrost heater for any visible signs of damage such as burns, breaks, or discoloration. Replace if needed. Perform a continuity test to check if the defrost heater is functioning by setting the clamp meter to the resistance or ohm setting and placing the clamp meter probes on each end of the heater element. Check continuity between clamp meter points A and B. The heater has continuity. Measure the resistance of the heater and document it in the table. If the operating voltage is 220 volts AC, connect the power source as per the provided diagram for 2 minutes. Then disconnect the power source. Touch the heater with your finger and observe if heat is generated. If heat is produced, the heater is functioning correctly. Now, let us see the process for checking, fault finding, and testing various electrical accessories in a refrigerator, including thermostat, timer, defrost heaters, bimetal air louvers, and other system components. Task 4. Checking and testing positive temperature coefficient (PTC) relay in a frost-free refrigerator. Find the PTC relay, usually situated near the compressor, often covered by a plastic or metal housing. Carefully remove the cover or housing, protecting the PTC relay, handling the relay and its wiring with care. Conduct a visual examination. Look for any signs of damage or burning on the relay, connectors, or wires, as visible damage could indicate a problem. Identify the relay pins or terminals. Typically, there are three: running terminal marked as A, starting terminal marked as B, and common terminal marked as C. Set your clamp meter to the continuity or resistance setting. Disconnect the wires attached to the relay. Check continuity between C and A with the clamp meter. Continuity is OK. A terminal is connected with the main winding. B terminal is connected with starting winding. Check resistance between C and B. Resistance should be approximately 30 ohms. Connect the relay to the FHP compressor. Allow the compressor to run for 5 minutes. Disconnect the power supply and measure the resistance between C and B. The resistance should be approximately 30 ohms. Task 5. Checking and testing overload protector in a frost-free refrigerator. Find the overload protector typically connected to the side of the compressor or positioned nearby. It may be housed with a plastic or metal cover. Remove the cover or housing protecting the overload protector. Handle the components and wiring with caution. Examine the overload protector for any visible signs of damage such as burns, discoloration, or a rattling sound which might indicate internal damage. Carefully disconnect the wires connected to the overload protector from the compressor terminals. Set your clamp meter to the continuity or resistance setting. Place one probe on each terminal of the overload protector. Check continuity with the test lamp between terminals 1 and 2 and 3 as well. If the bulb glows, the overload protector OLP is functioning correctly. Task 6. Checking and testing evaporator fan motor in a frost-free refrigerator. Find the evaporator fan motor typically located in the freezer compartment behind a panel or cover. Visually inspect the fan blades and the motor for any visible signs of damage, obstruction, or excessive dirt accumulation. Look for irregularities such as worn-out wires, burnt parts, or physical damage. With the power disconnected, manually rotate the fan blades to check for smooth movement. The blades should spin freely without any obstruction or resistance. If it is hard to turn, there might be a mechanical issue with the motor. Disconnect the wires connected to the evaporator fan motor. Set your clamp meter to the continuity or resistance setting. Test the continuity of the motor winding with a test lamp. If the bulb glows, it indicates that continuity is satisfactory. Use a low wattage bulb test lamp due to the very narrow winding wire used in the timer and evaporator fan. Connect the motor to the power supply. Run the motor and observe if the motor shafts run smoothly. If it does, the fan motor is working properly. Recap.
In this topic, we have come to know how to check and test timer, check and test bimetal thermostat, check and test defrost heater, check and test PTC relay, check and test overload protector, check and test the evaporator fan motor in a frost-free refrigerator. I hope you all understood the processes like checking, fault finding, and testing electrical accessories such as thermostats, timers, defrost heaters, bimetal air louvers, and other system components. Thank you, students, and let us meet in the next session. Bye. Hello students, welcome to this module on refrigeration and air conditioning. In this session, we are going to know about checking the air distribution system of a frost-free refrigerator.
Objectives. By the end of this exercise, you will be able to check the airflow in the freezer compartment, fresh food compartment, and, if available, the meat keeper compartment. Use a remote sensing bulb thermometer to check the temperature in the freezer compartment, fresh food compartment, and meat keeper compartment. Check for the accumulation of frost in the freezer compartments and the meat keeper department, particularly in areas where high humid air flows into the fresh food compartment. Check for any visible blockages or obstructions in the air ducts or vents. Clear away debris or items that may block the airflow. Inspect the ductwork for any damage or disconnections that might block proper airflow. Let us now take a look at the tools, equipment, and consumables needed for checking air distribution systems in a frost-free refrigerator. Tools, equipment, and consumables. Thermometer with remote bulb sensor. Set of screwdrivers. Set of Allen keys if necessary. Domestic frost-free refrigerator double door. 5 amperes fuse wire and insulation tape. Cotton waste. Now, let us see the preparations needed for checking the air distribution system in a frost-free refrigerator. Task 1. Check the airflow in the freezer compartment, fresh food compartment, and, if provided, the meat keeper compartment of a frost-free refrigerator. Inspect for any visible blockages or obstructions in the air ducts or vents. Remove any debris or items that may block the airflow. Inspect for damaged or disconnected ductwork that may block the proper airflow. Turn on the refrigerator and ensure it is fully loaded with items in both the fresh food and frozen food compartments. Allow the refrigerator to run for at least 2 hours before proceeding with further tasks. Monitor temperature variations across different sections of the refrigerator. Variations in temperature might indicate uneven airflow distribution. Open the refrigerator door, remove the door switch, and short the terminal with 5 amperes fuse wire. Insulate the open terminals with insulation tape and reinstall the door switch. This will make the evaporator fan run continuously. Feel the airflow with your hand in the freezer and fresh food compartments to make sure the evaporator fan is running. If the refrigerator is running but not reaching the required temperatures, stop the unit and open the cover of the evaporator fan compartment using short screwdrivers. Verify whether the fan blade is firmly attached with the blade set screws. Tighten the screws if necessary and reinstall the cover of the evaporator fan compartment. Task 2. Check for frost accumulation in the freezer compartment and meat keeper compartment, as well as high humid air flowing in the fresh food compartment. Insert thin paper between the door gasket and the gasket sealing area on the body of the refrigerator with the door closed. Pull out the paper to check if the gasket seals properly. If the paper comes out easily, it indicates a sealing issue, allowing moisture from the surrounding air to enter and deposit as frost inside the freezer cabinet. Change the door gasket to prevent moisture leakage from the surroundings and improve sealing. Reset the thermostat to the normal cooler position from a low temperature setting. Allow the refrigerator to run and observe the thermostat setting. It should trip to a normal cool position. If the thermostat does not trip to a normal cool position, remove and replace the thermostat. Check the condition of the heater's time delay switch. If a defect is found due to long run, it may stop heaters from running, leading to frost accumulation. Remove the defective time delay switch and replace it with a new one to ensure proper functioning. Recap.
In this topic, we came to know about how to check the airflow in the freezer compartment, fresh food compartment, and meat keeper compartment if available. Measure the temperature using a remote sensing bulb thermometer in the freezer compartment, fresh food compartment, and meat keeper compartment. Inspect for frost accumulation in the freezer compartments and meat keeper section, along with observing high humidity in the fresh food compartment. Examine the air ducts or vents for any visible blockages or obstructions. Remove any debris or items blocking proper airflow. Inspect the ductwork for any damage or disconnection that could block proper airflow. I hope you all understood the processes of checking the air distribution system in a frost-free refrigerator. Thank you, students, and let us meet in the next session. Bye. Hello, students. Welcome to this module on refrigeration and air conditioning. In this session, we are going to know about servicing a frost-free refrigerator.
Objectives. By the end of this exercise, you will be able to service the condensing unit of the refrigerator, service the evaporator cabin of the refrigerator, service the inner and outer cabinet of the refrigerator for maintenance, evaluate the operation of the refrigerator. Let us now take a look at the tools, equipment, and consumables needed for servicing of a frost-free refrigerator. Tools, equipments, and consumables. Thermometer, tongue tester, voltmeter, screwdriver, cutting plier, frost-free refrigerator, a small air blower, nylon brush, clean cloth, mild detergent powder, bucket of water, oil can. Now, let us see the preparations needed for servicing a frost-free refrigerator. Task 1. Service the condensing unit of the refrigerator. Ensure proper safety measures by wearing gloves and safety goggles, especially when dealing with refrigerants or cleaning agents. Work in a well-ventilated area to avoid inhaling fumes or gases. Switch off the refrigerator and disconnect the plug from the socket. Remove items stored inside the refrigerator and gently pull the unit forward. Unscrew the back cover to expose the condensing unit. Use a vacuum cleaner with a brush attachment or a coil cleaning brush to remove dust, dirt, and debris from the condenser coils. Brush or vacuum gently in the direction of the coils to prevent damage, ensuring thorough cleaning for improved efficiency. Connect the air blower to the socket and blow air onto the condenser fins. Clean the fins with a nylon brush, including the compressor, to remove dust. Turn off the blower. Inspect the condenser coils, fan blades, compressor, and electrical connections for any signs of damage, corrosion, or wear. Wipe the compressor and condenser with a dry cloth. Check the fan's functionality by manually spinning it if possible to detect obstructions or unusual noises. Lubricate the fan motor and wipe the fan motor and the condensing unit's base. Ensure the fan spins freely without resistance after cleaning. After servicing, cover the back and securely tighten the screws. Task 2. Service the evaporator cabin of the frost-free refrigerator. Ensure you use safety gear such as gloves and safety goggles to protect yourself during this task. Work in a well-ventilated area to avoid exposure to fumes or gases. Access the evaporator cabin by removing the cover panel or drawers inside the freezer. Open the top door of the cabin and clean the freezer cabin by wiping it with a mild detergent solution soaked cloth. Wipe it again with a clean water soaked cloth and finally wipe it with a dry cloth. Ensure that the drainage system connected to the evaporator cabin. Clean the drain tube if necessary to prevent water collection. Check the drain pan beneath the evaporator cabin for any dirt or residue and clean it thoroughly. Remove the evaporator fan grill and examine the evaporator fan for any debris or obstructions. Clean the fan blades and the grill with a dry cloth. Then fix the grill. Keep the top door open until the evaporator cabin becomes dry. Then close it. Now, let us see the process for servicing of frost-free refrigerator. Task 3. Service the outer and inner cabinet and door of the frost-free refrigerator. Use safety gear like gloves, and safety goggles to protect yourself. Work in a well-ventilated area to avoid exposure to fumes or gases. Close the door slowly and ensure the door is pulled by the magnetic arrangement when it reaches the nearest closing point. Take a 4 cm breadth by 10 cm length newspaper, place it so that half of it is visible outside on the edge of the door and close it. Now, pull the paper and check if it is held tightly by the gasket. Use this method to check all around the door gasket. If, in certain places, the gasket is not holding tight, assume there is a chance of cool air leaking from the inside. Fold the newspaper neatly and insert it between the gasket and the door inner wall, ensuring that the paper is not visible. Close the door and check if the door shuts firmly. If the door leaves a gap or does not reach the magnetic seal when closing slowly, the fridge level needs to be balanced for automatic closing. Adjust the bottom level screws to make the door close automatically in balance when closed slowly. Lubricate the door hinges and latches using an oil can. Then, settle the shelves in their proper places. Clean the handle, lock, hinges and nameplate with a soft wet cloth, then wipe with dry cloth. Check the thermostat temperature control knob and set it to the normal or center range for usual operation. After wiping the external area of the fridge, apply a small amount of fridge wax polish and polish until all sides shine with a soft cloth. Connect the plug and switch on the refrigerator. Open the door and check if the inner cabinet light is glowing. Test the off-on function by pushing the door switch and releasing it. After 10 minutes, touch the evaporator plate and feel the chillness. Now, the refrigerator is ready and you can load food items and cool drinks into the proper racks. Task 4. Test the operation of a frost-free refrigerator. After checking the electrical and mechanical components, reassemble the unit and proceed to test its performance. Ensure that the doors of the unit are properly closed. Plug in the refrigerator and allow it to stabilize. Set the desired temperature settings for the freezer and fresh food compartments as per the refrigerator's manual recommendations. Listen for the sound of the compressor starting when the refrigerator is turned on. It typically emits a low hum when running. Check if the condenser fan located near the compressor is running smoothly without any unusual sounds. Feel the air circulation in both the freezer and fresh food compartments. The air should be cool and consistent. Use a thermometer to check the temperatures in different compartments after a few hours of operation and ensure they are within the recommended range. Typically 0 degree Fahrenheit for the freezer and around 37 to 40 degrees Fahrenheit for the fresh food section. Fill the ice tray with water and place it in the freezer compartment. Set the thermostat knob to the normal position, medium cool. Place the sensing probe of a digital thermometer inside the cabinet. Let the unit run continuously for 2 hours without any interruption. After 2 hours, open the freezer door and check if the water in the ice tray has become solid ice. Note the temperature shown on the digital thermometer and compare it with the initial temperature. Ensure that the unit is running normally.
Recap. In this topic, we came to know about how to service the condensing unit of the refrigerator, service the evaporator cabin of the refrigerator, service the inner and outer cabinet of the refrigerator for maintenance, evaluate the operation of the refrigerator. I hope you all understood the process of servicing a frost-free refrigerator. Thank you, students, and let us meet in the next session. Bye. Hello, students. Welcome to this module on refrigeration and air conditioning. In this session, we are going to learn about identifying 3 and 4 door no frost refrigerators.
Objectives. By the end of this exercise, you will be able to identify a 3-door refrigerator, identify a 4-door refrigerator, identify a normal refrigerator, distinguish between a normal refrigerator, 3 and 4-door refrigerators. Let us now take a look at the tools, equipment, and consumables needed for identifying 3 and 4-door no frost refrigerators. Tools, equipments, and consumables. Line tester, screwdriver, cutting plier, 3-door refrigerator, 4-door refrigerator, clean cloth. Now, let us see the preparations needed for identifying 3 and 4-door no frost refrigerators. A 3-door refrigerator has 3 separate doors, 2 for the refrigerator compartment and 1 for the freezer compartment. Most refrigerators either have side-by-side doors or French door designs. In a side-by-side model, the refrigerator and freezer compartments are vertically divided, each with its own door opening from the center. In a French door model, the refrigerator compartment is on top with 2 doors and the freezer is a drawer-style compartment at the bottom. Look for manufacturer information on a sticker or label inside the refrigerator, around the door frame, or on the back. This label typically includes the model number, serial number, and sometimes the refrigerator's style. Measure the width of the refrigerator to confirm if it is wider than the standard models, as 3-door refrigerators often have increased capacity. Identify the 3-door refrigerator, inspect its construction, and label the parts. Incandescent light in selected models. LED light in selected models. Flipper guide. Ice maker. Ice bin. Water filter. Dairy compartment. Air filter. Spill safe shelves. Can rack in selected models. Flipper mullion. Crisper dryer. Store more dryer. Door bin. Adjustable hinges. Freezer baskets. Toe grill. Task 2. Identify a 4-door no frost refrigerator. A 4-door refrigerator as the name suggests, will have 4 separate doors. Examine the refrigerator by opening it and counting the number of doors. There will be typically 2 doors for the refrigerator compartment and 2 doors for the freezer compartment. 4-door refrigerators are generally wider than traditional standard models due to their increased capacity. Measure the width of the refrigerator to confirm if it is wider than standard models. Manufacturers usually place a sticker or label inside the refrigerator, around the door frame, or on the back of the appliance containing information such as the model number, serial number, and sometimes the configuration style of the refrigerator. Identify the 4-door refrigerator by visually inspecting its construction and parts. Label the parts based on the visual inspection. Incandescent light in selected models. LED light in selected models. Flipper guide. Ice maker. Ice bin. Water filter. Dairy compartment. Air filter. Spill safe shelves. Can rack in selected models. Flipper mullion. Crisper dryer. Store more dryer. Door bin. Now, let us see the process for identifying 3 and 4-door no-frost refrigerators. Task 3. Distinguish between a normal refrigerator and a 3 and 4-door no-frost refrigerator. Examine the construction and design features of both refrigerators. Identify key differences between the 2 types of refrigerators and make notes accordingly. Normal refrigerators. Standard refrigerators usually come in a single or double-door design with 1 door for the refrigerator compartment and other for the freezer. These refrigerators commonly include a top or bottom freezer compartment accessed through a single door. Standard models often offer fewer shelves, compartments, and door bins, providing limited organization options for food items. Standard models have a smaller storage capacity compared to 3 or 4-door models. Standard refrigerators come with basic features such as temperature control, interior lighting, and adjustable shelves, but do not offer advanced features. 3 and 4-door refrigerators. These refrigerator models have 3 in the case of 3-door or 4 in the case of 4-door separate doors, creating distinct compartments for various types of food. Most 3 and 4-door models follow a French door style for the refrigerator section, offering broad and convenient access. With more shelves, drawers, and door bins, they provide better organization and storage options for various food items. 3 and 4-door refrigerators generally have larger capacities, providing more storage space for groceries and items of different sizes. These models often come with separate freezer compartments or drawers, making it easier to organize and find frozen foods. They may include external ice and water dispensers, exact temperature control for different compartments, and settings that save energy. These refrigerators usually have adjustable shelves and dividers to adjust for bigger or differently shaped items. Some models come with energy-saving features, improving power consumption compared to standard refrigerators. 3 and 4-door refrigerators usually look modern and attractive, making them stand out in kitchens because of their stylish design. Recap.
In this topic, we came to know about how to identify a 3-door refrigerator, identify a 4-door refrigerator, identify a normal refrigerator, distinguish between a normal refrigerator, 3 and 4-door refrigerators. I hope you all understood the process of identifying 3 and 4-door no-frost refrigerators. Thank you, students, and let us meet in the next session. Bye.
Good morning, ladies and gentlemen. In recent days, you would have seen that 3D printing as a form of rapid construction technology has picked up a lot of imagination and a lot of traction.